Hi everybody, this is Mr. Bowman. So today we're looking at completing proofs involving congruent triangles using ASA and AAS. These are very similar to the proofs with SSS and SAS. But the only real difference is they can give us some more stuff because there's so many angles involved, and we've covered a lot of stuff about angles here. But it's pretty similar. We're still start with our givens, work through, and try and find three congruent statements, and then make our triangle congruent statement. So what do we know here? So I know ACB is a right angle. I went ahead and marked some of this ahead of time as I was reasoning through it here. ACD is a right angle, so these are both right angles. And then our last one here, BAC is congruent to DAC. So I know these two are also congruent. Okay. So lines 1 and 2 are completely given for you. It's a right angle which is given. That's a right angle which is given. This one they didn't put in here yet. So let's see if we can figure out what's going on here. So it says ACB is congruent, so ACB here is congruent to ACD. This is actually not one of our given statements. Notice our angle here is actually BAC, not ACB. So the question is, why are these two congruent? Well, it's because they're both right angles, right? We know that right angles are 90 degrees, so if they're both right angles, they're both 90 degrees. So this would be all right angles are congruent. Okay, so that's how I know that those two have to match, because they're both right angles. Now jumping down here, it says angle BAC is congruent to what? Based on a given, so that's where I can bring this one down. So angle BAC is congruent to DAC. Okay, and then on line 5 here, we have AC is congruent to what by the reflexive property. You don't even really need the picture for this one, but we're still going to mark it. So remember, anytime the reflexive property has to be something that's equal to itself or congruent to itself, so we have a congruent statement here. So AC is going to be congruent to itself. It's another one of those shared sides that we looked at. Okay. So now, looking at my picture, this is a little bit trickier because previously we just had to figure out which pieces we had because there was different combinations, right? We had SSS, so if I knew all three sides, that was the choice. And we had SAS, so if I had two sides and angle, that was our choice. Here, they're both two angles and a side. So the trick is, where is our side? Is it touching both of the angles or just touching like here? Or is it just touching one of the angles and then not touching the other one? So let's look at our picture. Our side is this middle piece right here. If I look at one of those triangles, is that side touching both arcs? And the answer is yes, it's touching this one here and this one. So I want the one that's where the S is touching both of the A's there. So this is going to be the ASA congruence property. And you're all set.